Very good morning to 11th standard students of St. John's. Which chapter we are in? Can you immediately say the answer which chapter we are in? Even by seeing this, you can easily say chapter 4 we are in. What is the name of the chapter? Combinatorics and mathematical induction. Right? So far, we have discussed combinatorics. We have seen two things. One is permutations and combinations. Many times I told you permutation means arrangement, combinations means selection. In both we read properties of them, and also we did few problems based on permutations and combinations. Now after completing that, in this chapter we saw only three things. One is permutation, first one. Second one is combination. And the final one, mathematical induction. I told you clearly that mathematical induction helps us to develop a formula. If we have found out new numerical formulas, we can prove what we have found out is correct using mathematical induction. We have seen so many examples also in the previous classes. If you see all the problems are of same kind. If you just observe all the sums, all the problems will carry only three steps. What are they? First, we will try to prove the result is true for n is equal to 1. Then we will take the result is true for n is equal to k. We will assume that. By assuming that, we have to prove the result is true for n is equal to k plus 1. That is, p of k plus 1 is true. If we do these three things, then our statement becomes valid. This is what we are seeing in mathematical induction so far. Now in this class also we are going to see last few problems based on mathematical induction. Mathematical induction means again all the problems will have only three steps. What are they? P of 1 is true, we have to prove. P of k is true, we should assume. P of k plus 1 is true, we have to prove. So we will see few problems in mathematical induction in this class. With that we will complete this chapter. Question number 41. Using the mathematical induction, show that for any real number n, this is the statement that they are giving to us. What is this? 1 by 1 into 2 into 3 plus 1 by 2 into 3 into 4 plus etc. plus 1 by, see if you see three terms, n plus 1, n plus 2. It goes on like that. So if we add terms like this, the answer is n into n plus 3 by 4 into n plus 1, n plus 2. So what is the first step? What is the statement given to us? We will consider that as P of n. So P of n is nothing but our statement. So this is our statement. This is what we need to prove. We need to prove this is a formula using what? Mathematical induction. Using mathematical induction. So first step is we need to prove that the result is true for n is equal to 1. P of 1 is true. So we will take LHS. P of 1 means I should take only one term. So 1 by 1 into 2 into 3. 2 into 3 is 6. 1 by 6 is the value for LHS. Now we will calculate RHS, which means in place of n you put 1. So 1 plus 3 by 4. In place of n 1. So 1 plus 1. Again in place of n 1 plus 2. 1 plus 3, 4, and this 4 gets cancelled, right? 4 gets cancelled. So this is 2, this is 3. 2 3s are 6, so 1 by 6. Since we are getting the same answer for LHS and RHS, we say they are equal, hence P of 1 is true. So this is first step. First step we have proved. What is the second step? We have to assume P of k is true. What is the meaning? So in this question, in this statement, we should write this. Replace n by k. N plus 1 means k plus 1. N plus 2 means k plus 2. So this is nothing but P of k is true means even in the right hand side I can replace n by k, k plus 3, 4, k plus 1, k plus 2. So this is the result that I am going to take. I assume that this is true. By assuming this is true, what we have to do? We need to prove P of k plus 1 is true. That is, the result is true for the next step. If you listen the previous video classes, you will understand we will always find this. What is to be added, what we have to get, right? In all the problems we are doing like this. In the examination point of view, you need not write this. This is for our understanding. So what is to add? How to find it? But just you see LHS and take the last term. In that you replace k by k plus 1. So 1 by k place we should write k plus 1. Again in k place we should write k plus 1. Already plus 1 is there, so k plus 1 plus 1. Here also k plus 1 plus 2. So this becomes k plus 1, k plus 2, k plus 3. So what is our aim? We should add this term to both sides of equation 1. So before itself we are finding out that what is the term to be added to both sides. Okay, after adding, what is the answer that should come in the RHS? That is what we should get as the answer that we are writing here. How to find out that? Just replace in RHS, you replace k by k plus 1, that's all. In place of k, put k plus 1. Again in place of k, k plus 1. Again plus 3 is there, write it. Similarly for place of k, k plus 1. In place of k, k plus 1. So what happens here? This becomes k plus 4. This becomes k plus 2, k plus 3. So this is the answer that we need to get. If this answer we got, we will say, if we get this answer, we will say P of k plus 1 is true. So again I am telling, this is not for examination. We need not write this in the examination. We should know after getting this equation 1. What is equation 1? Assuming P of k is true. So after assuming this, we should know what is the term to be added to both sides. After adding, what is the answer that we should get in the RHS, we should know. So that is why we are writing this. So remember, what is the next step? Adding this to both sides of equation 1. When we simplify RHS, we should get this as the answer. What is the answer? K plus 1, k plus 4, 4 into k plus 2, k plus 3 we should get. So ultimately what is our next step? Adding this. This means what? 1 by k plus 1, k plus 2, k plus 3 to both sides of equation 1. So if you see, that is what we are writing. Adding this term to both sides of equation 1. So up from this to this LHS, since we are adding this term, plus this is written. Similarly, RHS of equation 1 is this. With that we are adding this term. So this term is added to both sides of equation 1. Now if we need to simplify this RHS, if you see, I am going to take LCM. Here k plus 1, k plus 2 present. Here k plus 1, k plus 2, k plus 3 is present. So this will come in the LCM. K plus 1, k plus 2, k plus 3. 4 is present, so 4 will be included in the LCM. Right? So LCM for this denominator and this denominator is 4 into k plus 1, k plus 2, k plus 3. Now if you see the first term, 4 is present, k plus 1 is present, k plus 2 is present. What is absent here? K plus 3. So that k plus 3 should come in the numerator. If it comes in the numerator, already on k plus 3 is present, so it becomes whole square. And here if you compare LCM, only 4 is missing. All the other 3 terms are present. So numerator 4 should come. So plus 4. This is nothing but by taking LCM. After this, I am writing this k as it is. A plus b whole square expansion plus 4 denominator. Multiplying this k inside, taking k inside the bracket, we will get that, right? So k is taken inside the bracket. So that is the next step. Plus 4 by denominator. And another important thing you listen here, for this numerator, I am doing synthetic division. See, if you see this, the coefficient is 1, 6, 9, 4. Doing synthetic division using minus 1. Why I am using minus 1 means, if I simply see here, 1 plus 9, 10, 6 plus 4, 10. If it comes like that, I easily know that minus 1 will be a factor. Sorry, minus 1 is a root. See, coefficient of k cube is 1. 1 plus 9 is 10. 6 plus 4 is also 10. So I can do the synthetic division using minus 1. When I do that, I should put 0, 1 plus 0, 1, 1 into minus 1, minus 1, 6 minus 1, 5, 5 into minus 1, minus 5. When you subtract these two, 4, 4 into minus 1, minus 4. So this becomes 0. Since 0 comes, what should I say? X plus 1 is a factor, usually we will say. Since the equation is in terms of k, I should write k plus 1 is a factor. So since minus 1 is there, I should put k plus 1. And this is called quotient. How to write this? 1k square plus 5k plus 4. That is what is written here. K square plus 5k plus 4. So try to understand, this cubic equation is factorized here. This cubic equation is factorized like this using this synthetic division. Try to understand. Minus 1, 0, since 0 comes, for minus 1 I am writing k plus 1. For this quotient I am writing k square plus 5k plus 4 by this denominator. Right? Now factorizing this. How to factorize? 4 into 1, 4. Splitting 4 as 4 into 1, because 4 plus 1 gives this 5. So since 5 we are getting here, so I can say that this k square plus 5k plus 4 is written as k plus 4 into k plus 1. That is what is written here. By factorizing this, we are writing these two terms. Denominator as it is. Now I can cancel one, k plus 1, right? So balance is k plus 1, k plus 4. You can even cancel this. So 4 into k plus 2, k plus 3. This is what we need to get. If you see to get, this is the answer. Since this comes, we will say what? P of k plus 1 is true. Therefore, the given statement is true for all the real values n. So what is the statement given? It is a formula. So this can be accepted. So this is proved. This result is true, is proved. So this is what we are continuously doing in all the problems of mathematical induction. Even we are going to see few more problems on the same type. Try to understand. With that we will try to with that we will complete this chapter. We will go for the next sum, question number 42. Question number 42. Again, using the mathematical induction, show that for any natural number n, this is the result. This is the result means 1 by 2 into 5, 1 by 5 into 8, 1 by 8 into 11, it goes on like that, 1 by 3n minus 1, 3n plus 2. If we add terms like this, the answer is n by 6n plus 4. This is what the statement is. We need to prove it is true by using mathematical induction. So I am going to explain quickly. P of n is nothing but our statement. So the question is taken as P of n. What is the first step? P of 1 is true, which means take the first term alone, 1 by 10. RHS means in place of n you put 1. So 1 by 6 ones are 6 plus 4, 1 by 10, they are equal. Therefore P of 1 is true. First part is over. Second part, we have to assume P of k is true, which means in this statement I should write in place of n you put k. So 3k plus 2, right hand side also n is replaced by k. So this is the result which we are taking as true, assuming that this is true. This is equation number 1. What we have to prove now? P of k plus 1 is true. That is what we need to prove. So we have to find two things. What is to be added? That is how to find that. See the last term of LHS. In that, in place of k you put k plus 1. In place of k you put k plus 1. So bringing this 3 inside, what happens? 3k plus 3 minus 1. Plus 3 minus 1 is 2. 3k plus 2. Bringing this 3 inside, 3k plus 3 plus 2. 3 plus 2 is 5. So 3k plus 5. So this is the term that has to be added to equation 1 on both sides. Okay, what is the result that we should get? That is to get. How to find that? In the RHS, you put k, replace k by k plus 1. So numerator becomes k plus 1. In place of k, you write k plus 1, then plus 4. Bring the 6 inside. 6k plus 6 plus 4. 6 plus 4, 10. So finally we should get this as the answer. K plus 1 by 6k plus 10. So what is the next step? Adding 1 by 3k plus 2 into 3k plus 5 on both sides of equation number 1. That will be the next step. So adding 1 by 3k plus 2, 3k plus 5 to equation number 1 on both sides. So this is from this to this first equation. Now we are adding this term equal to, this is RHS. We are adding this term 1 by 3k plus 2 into 3k plus 5. Now out of these two, I am taking 2 as common from 6k plus 4 and writing like this, and the second term is written as it is. Now if you compare these two, 3k plus 2 is common. So 1 by 3k plus 2 is taken common. Balance will be k by 2. Here if it goes out means balance will be 1 by 3k plus 5. So this as it is, this is taking LCM. 3k plus 5 will come here, so k into 3k plus 5, 2 will cross multiply 2. LCM is these two things, 2 into 3k plus 5. So bringing k inside, right? I think you will understand clearly. Bringing k inside the bracket, 3k square plus 5k, 3k square plus 5k plus 2 divided by 2 into 3k plus 2, 3k plus 5. Factorizing. How to factorize? Multiply this 2 with 3 becomes 6. Factorizing 6. 3 2s are 6. 3 plus 2 is 5. Since 3 is present, we should divide both the numbers by 3. So this will get cancelled. It becomes 1. So 1 is written as k plus 1. 2 by 3 is written as 3k plus 2. So factorizing this, we are getting these two terms. Denominator as it is. 3k plus 2 gets cancelled. So k plus 1 by, if you bring this 2 inside, it becomes 6k plus 10. If you see what is to get, this is the answer to get. K plus 1 by 6k plus 10. So we will say P of k plus 1 is true. Therefore given statement is true for all the values of n. Hence what is the formula given is correct, and we have proved this using mathematical induction. This is what we are continuously doing. We will go for the next sum. Question number 43. Use induction. Induction means mathematical induction. Use induction to prove that n cubed minus 7n plus 3 is divisible by 3 for all natural numbers n. If you see, this is slightly different problem as we compared to previous problems. N cubed minus 7n plus 3 is divisible by 3 for all natural numbers n. So this is the result. N cubed minus 7n plus 3 is divisible by 3 is the result that we are going to prove using mathematical induction. So that we are taking as P of n. N cubed minus 7n plus 3 is divisible by 3 where n belongs to natural numbers. As usual, first step is to prove P of 1 is true. So in this sum, P of 1 means replace n by 1. So 1 cube 1, 7 into 1 7 plus 3. You simplify this. 1 minus 7 minus 6, minus 6 plus 3 is minus 3. Minus 3 definitely is divisible by 3, right? Since minus 3 is divisible by 3, P of 1 is true. So if we proved the first part, now we have to assume P of k is true. What is the meaning? In this statement, replace n by k. So k cube minus 7k plus 3 is divisible by 3. This is what we are taking. Since this term is divisible by 3, I can write this as some 3 into some number, 3l. L is any number. This is very important. You should know how it is. Since this term is divisible by 3, this term is written as 3 into some number. Since it is divisible by 3, it will be a multiple of 3. So 3l. Even you can write 3k or 3r, 3s, your wish. Some multiple of 3, right? So this is equation number 1. This result we are having. What we need to prove? P of k plus 1 is true. This is what we need to prove. Now if you see the result, P of k plus 1 means you should replace n by k plus 1. That is, in place of n, I should put k plus 1 whole power 3 minus 7 into, in place of n, I should write k plus 1 plus 3. Now I need to prove that this term is divisible by 3. This is what we need to prove. Now This I am taking k plus 1 whole cube, a plus b whole cube formula applying here, a cube plus 3a square b plus 3ab cube plus, I think I'm telling it wrongly, a cube plus 3a square b plus 3ab square plus b cube. I'll write the formula here so that you can just compare and read. I'll write in the rough column a plus b whole cube, and the formula is a cube plus 3a square b plus 3ab square plus b cube. So this is the formula. Now a in place of a, k is present, so a cube, k cube, 3a square b, 3a square means k square, b is 1, so need not write, plus 3ab square, 3a is k, b is 1, b square is also 1, so need not write, plus b cube, plus 1 cube is 1. Then bringing 7 inside, minus 7k minus 7, then this plus 3. Now after this, just see this, see the arrangement. K cube I am writing here. So this k cube is written here, minus 7k is written here, plus 3 is written here. Why I am collecting this means, this is the result that I am having, k cube minus 7k plus 3. So I am collecting those terms, k cube minus 7k plus 3 is collected separately. What are the terms that remaining? 3k square plus 3k. When you combine this 1 and minus 7, it becomes minus 6. So try to understand, we are separating the terms, k cube minus 7k plus 3. Why we are collecting like this? Because the result that we are having. So collecting this, the remaining terms is written, 1 minus 7 becomes minus 6. So for this, I can use this result, first equation. So k cube minus 7k plus 3 means that can be replaced by 3l. So this term is replaced by 3l. We even will write by equation number 1. So using equation 1, this has become 3l. But if you see these terms, 3 can be taken as common outside. So k square plus k 6 means it will become 2. Now even for these two terms, which is common? 3 is common. So write the remaining thing, l plus k square plus k minus 2. So now what is the meaning? This is divisible by 3. Why? Because 3 into something. This is 3 into something, which means it is divisible by 3. Which is divisible by 3? We started this, right? So k plus 1 whole cube minus 7 into plus 3 is divisible by 3. Which means p of k plus 1 is true. Once p of k plus 1 becomes true, the statement becomes true. What is the statement? N cube minus 7n plus 3 is always divisible by 3 for all numbers n, where n is a natural number. Even if I put in place of n, if I put 1, 2, 3, 4, 10, 11, 12, anything, the answer, the final answer will be divisible by 3. So this is the result that we are proving using mathematical induction. I believe you will understand. If not, we will see one more example of one more problem of same type. We'll move on to problem number 44. Question number 44. Use mathematical induction to prove that 10 power n plus 3 in dot means into. Keep in mind, dot means into. 10 power n plus 3 into 4 to the power of n plus 2 plus 5 is divisible by 9. If you see previous problem, we proved it is divisible by 3. Here we are proving divisible by 9 for all natural numbers n. So this statement we will take as p of n. P of n means our statement. 10 power n plus 3 into 4 power n plus 2 plus 5 is divisible by 9. What is the first step? We have to prove p of 1 is true. So what is p of 1? Replace n by 1. 10 power 1, 10. If I put 1 here, 1 plus 2, 3. 4 power 3, that is what I have written, plus 5. So simplifying all these things, 4 cube, 64, 64 into 3, 192, 192 plus 5, 197 plus 10, 207. It is clearly divisible by 3 because 207 by 9, what is the answer? 2 9s are 18, balance 2, 23 will be the answer. So 207 is divisible by 9. Hence p of 1 is true. Next step is we should assume p of k is true. What is the meaning? In the statement, replace n by k. replace n by k. So this term is divisible by 9, we are assuming. So how to write that? So this entire term can be considered as 9 into some number. Since it is divisible by 9, we can write this as 9l. Even you can write 9k, 9r, 9s, your wish. Some multiple of 9. What is to prove? P of k plus 1 is true. P of k plus 1 means what is the meaning? In the statement, replace n by k plus 1, 10 power k plus 1 plus 3 into 4 power k plus 1 plus 2. The meaning is k plus 3 and then this plus 5. So we need to prove that this term is divisible by 9. We have to prove that this is divisible by 9. Now understand, try to understand, listen carefully, then only you will understand. Now see this, 10 power k plus 1 is written as 10 power k into 10 power 1. So I am splitting this power into two terms. Keep that in your mind, this into, not plus. So 10 power k into 10 power 1 plus 3 into 4 power k plus 3, no. So that is splitted as k plus 2 plus 1. Since base is same, I should add the power. If I add the power, what happens? K plus 2 plus 1 becomes k plus 3. So k plus 3 is splitted as 4 power k plus 2 into 4 power 1. So this is splitted as 2. Then plus 5. Try to understand. 10 power k, 10 is written as 9 plus 1 plus 3 into 4 power k plus 2. 4 is written as 3 plus 1. Then plus 5. Now taking this 10 power k inside, so 9 into 10 power, dot means into, keep that in mind, 9 into 10 power k. 10 power k when goes to 1, it becomes 10 power k into 1, 10 power k plus, so 10 power k is taken inside and becomes 2 terms, plus this is taken to this bracket. What happens? 3 into 3, 9 into 4 power k plus 2. Then those terms is taken to 1, becomes plus 3 into 4 power k plus 2. So again taking this inside the 2. So first becomes 3 into 3 is 9 into 4 power k plus 2. When goes to this 1 means it will come as it is, 3 into 4 power k plus 2 plus 5. So you should understand the concept, otherwise it is difficult. How I am multiplying, I am slowly telling you. So now after this I am arranging the terms because I am having this result in my hand, first equation. So 10 power k plus, writing this 3 into 4 power k plus 2 plus 5, because for these terms I am having the result. So I am collecting those separately, 10 power k plus this plus this. What is remaining? This one, 9 into 10 power k plus 9 into 4 power k plus 2. Now for these three terms I am having this result. This is equal to 9l. So these three terms can be written as 9l plus, out of these two 9 is common. So take 9 as common and write the remaining things. And this comes because of equation 1. By equation 1 we are replacing this by 9l. Now from these two, which is common? 9 is common. So I can take that as common outside. So when take 9 as common outside, this we will be getting. So what is the meaning? 9 into something. So which means it is divisible by 9. Hence P of k plus 1 is true. Therefore the given statement is true. What is the given statement? 10 power n plus 3 into 4 power n plus 2 plus 5 is always divisible by 9. So this is how we are proving the result. We will see one more sum, last sum, and we will complete this chapter. Use mathematical induction to prove that 5 power n plus 1 plus 4 into 6 power n, when this is divisible by 20, it leaves a remainder 9 for all natural numbers n. So what is the question? Is taken as P of n. To prove P of 1 is true. P of 1 means what? Replace n by 1. 1 plus 1 is 2. 5 square is 25. If I put 1 here, 6 into 4 is 24. 49. What happens for 49? It 2 into 20 plus 9. So in 20 table, it is divisible by 2 times, but it leaves a remainder 9. So P of 1 is true. Why P of 1 is true? Because when 49 is divided by 20, remainder is 9. Now next we have to assume that P of k is true. What is the meaning of P of k is true? In statement you replace n by k. So 5 power k plus 1 plus 4 into 6 power k leaves a remainder 9 when divisible by 20. So this is the result that we are taking. So if you see now, that thing can be written as 20L plus 9. Why I am writing like this? Because it is divisible by 20, but at the same time it leaves a remainder 9. So this is taken as equation number 1. What is to prove? P of k plus 1 is true. What is P of k plus 1? Replace k plus 1 here. So it becomes k plus 2. 4 into 6 power k becomes k plus 1 is equal to 20 into something plus 9. So what is the meaning? This when divided by 20 leaves remainder 9. This is what we need to prove. So for that what we are doing, 5 power k plus 2 plus this, taking this LHS is written as k plus 2 is written as k plus 1 1. So splitting k plus 2 as these two terms plus 4 into splitting this as 6 power k into 6 power 1. In the next step, 5 power k plus 1, 5 is written as 4 plus 1. 4 into 6 power k, 6 is written as 5 plus 1. Bringing this inside, 4 into 5 power k plus 1. 5 power k plus 1 into 1 is 5 power k plus 1. Similarly, bringing this inside, 5 4s are 20 into 6 power k. Bringing this inside, 4 into 6 power k. Now after this, collecting the terms, 5 power k plus 1 plus 4 into 6 power k, this is collected because that result we are having here using equation 1. So we are collecting that separately. What is the remaining thing? 4 into 5 power k plus 1, 4 into, this is splitted as 5 power k into 5 power 1 plus 20 into 6 power k. For these two, the result is 20L plus 9. For this is for this bracket, this is the result. 20 is written here. 4 into 5 is nothing but 20. So 20 into 6 power k. This is 20 into 5 power k. Now see this. From this and this, take 20 as common. So that L plus 5 power k plus 6 power k and this plus 9 comes at the last. So what is the meaning? Assume that this is k. So 20k plus 9. So we started with P of k plus 1 and that is equal to some 20 into something plus 9. What is the meaning? So when it is divided by 20, it leaves a remainder 9. So it leaves a remainder 9 when divisible by 20. So P of k plus 1 is true. Hence the given statement is true for all the values. Hence 5 power n plus 1 plus 4 into 6 power n is divisible by 20. It leaves a remainder 9 for all natural numbers. So write this clearly in your classwork. With this we are completing chapter 4. Finish your classwork properly. Thank you, children.